everyone, we're going to sketch the curve with the given polar equation by first sketching the graph r as a function of theta in Cartesian coordinates. Basically, this problem is wanting you to compare the graphs. So basically, you're just graphing this. And we know that cosine usually starts at 1. We'll let this be 1, -1. And if I just graph this part first, usually the graph goes like this. If you go this way, usually it goes this way. That's your parent function. But for negative, that means you're just reflecting it. So basically, we're going to start here. It reflects over this x-axis, or let's call this the theta axis. So we start here, 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 and back to here. All right. So here's your graph. Now, this 1 just means it's a shift up by 1. So instead of starting at -1 here, we're going to start at 0. And then we're going to go, since we're shifting up 1, we're going to go up to 2. So it's going to be 1, 2, back to 0, back to 1, back to 0. So it looks like, let's see, did I do this right? So it should look like the same thing, so I did something wrong. Oh, go to, I'm skipping the 1. So 1, here we go. I was trying to do sine. Okay, so here's your graph. It looks like this. All right, something like that. All right, so there's your graph of r as a function of theta in Cartesian coordinates. Now we're going to sketch it given with the polar equation. Now for this one, what we're going to do, this is going to be a cardioid. It's with cosine. So that's a clue that this is going to be symmetric to our polar axis. And we can graph accordingly. So let's go ahead and assign values from 0 to pi, which I already did. I probably already did a video on this as well. So anyways, let's do this quickly. 0 maps to 0. Pi divided by 6 goes out a bit, just a little bit. And then pi over 3 is 1/2. So I'll just make it go out a little more. At pi over 2, we're at 1. And at 2 pi divided by 3, we're at 1.5. So there is 1.5 about there. At 5 pi over 6, that's 1.9, so that's close to 2. And at pi, we're at 2. So this is the upper portion of the cardioid. And then what you do is you just take the, use the fact that it's symmetric to the pole, and we're going to look at 11 pi over 6, and that's going to go to these same values. So this is going to go to really close to 0 here, and at pi divided by 3, that's going to be our 5 pi divided by 3, that's at 1/2. So make it go out a little bit more. At pi divided by 2, we're looking at that, that's going to go to 1. And you just compare like that. And this is going to be 1 and 1/2. And this is going to get close to 2. And then you have this. So that's kind of how you do it. So we only had to use our reflection part to get the full graph. Thank you. Have a nice day. Bye-bye.